Okay. Now, over time, what ended up happening here is math people, they started looking at slope in general. And they started thinking, well, this idea of slope allows us to figure out how the rate of change over a period of time. So slope came to be known as essentially average rate of change. So slope is the average rate of change. And so what math people started looking at doing is going, well, what if we were to try to determine the rate of change at a and get closer and closer. Well, the closer and closer that our 2 points were, what ended up happening is we end up getting something that's a little bit more closer to what the instantaneous rate of change is. In other words, what the rate of change would be if it was completely on top of itself. In other words, 2 points, the 2 points you used were in fact the exact same point. And if you did that, we ended up coming up with this tangent line. So as we get closer and closer, the slope of these secant lines get closer and closer and closer to allowing us to be able to get a better approximate for what the slope would be at an instant point on that graph, or the slope of the tangent line to a graph. So what ended up happening here is they ended up saying then, let's see if I can, that's what I want right there. Maybe, there it is. The closer the 2 points are that you are taking the slope of, the closer the slope becomes the slope of the tangent line to the point on the curve. So this slope, this value here, this tangent line, it ends up becoming what we call instantaneous rate of change. So slope is average rate of change. And if we get close enough, with the slope we're using is at that 1 point, that becomes the instantaneous rate of change. So another way to think of it here is, instead of using some x and y, what this is kind of this little graphic is symbolizing is, let's do c of f of c, and then let delta x, that's the distance between, the horizontal distance between the 2 points. So we have c f of c. So if we're finding the slope between this point and this point right here, the difference, the slope would always be the difference in the y's. So here's your delta y, your distance in y's, change in y's, minus your difference in x. And if that difference gets really close to 0, then it becomes that slope, that instantaneous rate of change. Well, what some math people do is they say, okay, well, we don't really like the delta x's and h's. Maybe we can use a little bit different value. And these are the values that we're going to go ahead and use. And they said, all right, let's just go ahead and graph that here. They said, what if we just go ahead and call this still any point on this y, on this graph. So we'll call it x and f of x. But this time, instead of calling it delta x, because all those x's become confusing, what if we call it h? Then this point right here would be x plus h. And this would be f of x plus h. And if you do that slope for those 2 points, it ends up giving you this, which we've seen before. That was the difference quotient. So this difference quotient ends up being the slope at a point on a graph, the instantaneous rate of change. And since instantaneous rate of change is pretty lengthy to call it, they end up, math people say, well, let's just call it a derivative. So the derivative, or the instantaneous rate of change, equals the difference quotient. So to kind of put this all in perspective here, we had average rate of change, we call that slope. Instantaneous rate of change, instantaneous rate of change is a derivative. And then we have that, if you notice, we have a formula or a symbol for derivative. So we don't have to write it out all the time. It's f apostrophe x. And apostrophe, we call it prime. So it's f prime of x. Allows us to find the slope of the tangent line. So that f apostrophe of x, we read that as f prime of x. And we can use that difference quotient to come up with something to allow us to find the slope at any point on the curve. So there you go. So what we're going to do here today, friends, we're going to use the difference quotient to allow us to find the derivative, and then use that derivative to evaluate the slope at a point. So on this one, it says, determine the slope of f of x equals x squared minus 2x minus 3 when x equals 3. So we first have to find the derivative for this function. So we use the difference quotient to find the derivative. So I can now go ahead and say that this is f prime of x equals the limit as h approaches 0. So here's our difference quotient, f of x plus h minus f of x all over h. And we're going to plug that in there so we can figure out what the derivative will be. So f of x plus a squared minus 2 times x plus h minus 3, so x plus h squared minus 2 times x plus h minus 3 minus the original function all over h. And this is how we can use what we can use to find the derivative. Notice, if you remember, our derivative is going to be still an expression, because we can use that expression to find the slope of any point on the curve. So x squared plus 2xh plus h squared minus 2x minus 2h minus 3. Then we have minus x squared plus 2x plus 3. So the x squareds are going to go away. I'm going to be left with 2xh plus h squared minus 2h all over h. So when we're doing that, I'm going to go ahead and cancel out my h in the bottom here. I have 2x. We have minus or plus h minus 2. And when I plug 0 in, I get 2x minus 2. In other words, this is my derivative. So this derivative here, this would allow me to evaluate the slope for any point on this curve. So let's just put that out here just so we're kind of clear on that. So remember, that means that f prime of x will allow us to find the slope of any x on f of x. That's what we found here. That's the whole point behind this. Now, so I can use this derivative and I can plug any x there, and that would be the instantaneous rate of change on that curve. Well, for me, I'm dealing with the instantaneous rate of change of 3. I want to find the slope of 3. So when I plug 3 in here, 2 times 3 minus 2, that would be 4. So the slope of f of x when x equals 3 is going to be equal to 4. All right, friends, why don't you guys go and pause the video and see if you guys can't try a little bit here with this next one. See what you guys can do with that. All right, let's see how you guys did. First up, we have our derivatives. It's the limit as h approaches 0 and of f of x plus h minus f of x all over h. So we're going to plug that all in. And you have x plus h squared plus 4 times x plus h minus x squared plus 4x. So we plug it all in there, and then we are going to start cleaning up a little bit. So we have x squared plus 2xh plus h squared plus 4x plus 4h minus x squared minus 4x. And the whole thing is over h. Let's see, what can we get rid of here? There's our 2xh. There's our h squared. 4x is going to go away, and then I have plus 4h all over h. So 2x plus h plus 4, and that would be equal to 2x plus 4. So that means our derivative then is 2x plus 4. And if I wanted to find the slope of the tangent line when x equals 3, I'm sorry, 1 this time, I'm going to just plug 1 in. 2 times 1 plus 4. All right. Hoping we're kind of starting to get kind of the hang of this a little bit here. Oops, there we go. Let's try a couple more of these here, friends. Now let's make these functions just a little bit more. Let's guys go ahead and pause the video and try this third one. See what you guys can do with that. All right, let's see how you all did here. So f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So we're going to plug all our numbers in here. So x plus h plus 3 minus root x plus 3 all over h. And if you notice, friends, it's pretty much one of the things we dealt with before is going to be our rationalizing. So we're going to multiply by the conjugate here. So those rules that we learned, those techniques we learned for evaluating limits, so they're going to come back into play here now. So whatever we do to the bottom, we do to the top. And that will be equal to the limit as h approaches 0, x plus h plus 3 minus x plus 3 all over h times so kind of like that. So the x's will cancel out, the 3's will cancel out. I'd be left with an h on top and an h on the bottom. So we have this whole thing here. And then when the h's cancel out, not sure why I wanted to rewrite the limit there, or the derivative there. There we go. The limit as h approaches 0. So we have nothing in the numerator. And in the denominator, we have x plus h plus 3 plus x plus 3. And when you plug 0 in there, you have 1 over the root x plus 3 plus root x plus 3. which is 1 over 2 root x plus 3. Now, friends, we have our derivative. So we just have to plug in our value now to figure out what the slope would be. So 1 over 2 times -2 plus 3, which would be 1. So this whole thing is 1/2. All righty. Well, friends, why don't you guys go ahead and try this next one and see what you come up with. Go for it. All right, let's see how you did. Let's see, we have f prime of x equals the limit. Notice we're always coming back to that difference quotient. If you don't have the difference quotient memorized, by the time you're done with this assignment, well, we have issues. Because we are just going to keep writing this over and over and over again. So that's the formal definition of a derivative right there, is that difference quotient. All right, so we're going to plug everything in here. So we have 4 over x plus h minus 4 over x, all of it over h. So I'm going to go ahead and put that over 1, and I'm going to multiply by the common denominator. Well, the common denominator is going to be x and x plus h. So the x plus h's will cancel out. We're left with 4x minus 4 times x plus h all over h times x plus h. So 4x minus 4h, we left with negative 4h on top, all over h times x plus h. So notice, now we're doing one that has a common denominator type problem. So all those evaluating techniques that we learned before, they do come back because there are different types of functions we can do derivatives of. H on the top and the bottom cancel out. I'm left with negative 4 over x times x plus h. You plug your negative 4 in there, or your 0 in for h, you get negative 4 over x times x, which is negative 4 over x squared. So there's our derivative. So f prime of x equals negative 4 over x squared. And we are going to evaluate it when x equals 1. So f prime of 1 equals negative 4 over 1 squared, which is negative 4. All right, so we're getting a lot of practice at using the difference quotient, right? Because the derivative is equal to that difference quotient. So the derivative is the instantaneous rate of change. The derivative is the slope of a tangent line at a given point on a curve. Well, since it's the slope of the tangent line on a curve, we should be able to just go ahead and figure out the equations of a tangent line. Now, a couple of things we have to go back and remember here. You guys have learned how to figure out the equation of a line. Equation, apparently I wanted an extra. We had the slope-intercept form, which is y equals mx plus b. And we had the point slope form, which is my personal favorite, which is one I'm going to ask that we use because this is one we would use in calculus. And let's see, I got to add some sub ones there. Where y sub 1 and x sub 1, that's just some point. Some point on the graph. So we're going to use point slope form. This one is our personal favorite one to use. So we like this one. I know you guys like slope intercept, but that one requires just a tad bit more work. This one doesn't. So the first thing we're going to do here is we're going to be asked to figure out the equation of the line tangent to f of x equals negative x squared plus 3 when x equals negative 3. So I guess the first thing I need to know is, well, what's the point that I'm going to be using? So if I plug negative 3 in here, I get negative 3 squared plus 2x. And I end up with negative 9 minus 6 equals a negative 15. So that means the point on this graph that I'm looking at here is the point to negative 3, negative 15. So now what I have to do to write the equation of my tangent line is I got to figure out the slope that goes with it. And that's where my derivative comes into play. So back to doing the difference quotient. So we have the limit as h approaches 0 of f of x plus h minus f of x all over h. So we're going to plug in all our numbers here. So negative x plus h squared plus 2 times x plus h minus f of x. So we do our derivative here. So f prime of x as h approaches 0. When I multiply this whole thing out, I get negative x squared minus 2xh minus h squared plus 2x plus 2h plus x squared and minus 2x all over h. By the time you get done with these guys, you are going to have the difference quotient down well. And when you get to calculus, there actually are some shortcuts that we learn along the way that makes this just a little bit faster. Some of you guys, as we've been going through these, some of you probably have already figured out what they are. But if you didn't, no harm, no foul. So h prime is 0. We have negative 2x minus h plus 2, which is equal to negative 2x plus 2. So there's our derivative. And when we plug our negative 3 in there, we end up getting our slope. So negative 2 times negative 3 plus 2, which is 8. So now we know what our point is. We have our slope. We can write the equation of our tangent line. So y minus y1 equals m times x minus x sub 1. So here's our m right here. And this up here, this is our x1, y1. So we're just going to plug in all these things here. So y minus y1 equals m times x minus x sub 1. So our y sub 1 was negative 15. And our y1 was negative 3. And our slope was 8. So we end up with y plus 15 equals 8 times x plus 3. All righty. Well, friends, wouldn't be fair if I didn't give you guys a chance to try one of these on your own, and then we will go ahead and call it. So go ahead and pause the video. I'm going to leave this up there while you pause it so you can use it as an example, and then we will talk about it. All righty, here we go. Let's give it a shot. First things first, got to figure out our point. We're going to plug that in there. So 2 squared plus 4 times 2 minus 5. 4, 8, that's 12 minus 5. That would be 7. So our point is going to be 2, 7. Now we're going to do our derivative. So the limit as h approaches 0 of f of x plus h minus f of x all over h. So we're going to have x plus h squared plus 4 times x plus h minus 5 minus f of x all over h. So we have our limit as h approaches 0. We have x squared plus 2xh plus h squared plus 4x plus 4h minus 5 minus x squared minus 4x plus 5. And we're just going to go ahead and start to clean up a lot of stuff here. And we have our 2xh, the x squareds went away, plus h squared. The 4x's went away, so we have a plus 4h, and the 5's went away. And then we divide out the h. 2x plus h plus 4, which is equal to 2x plus 4. And if we plug our 2 in there, f prime of 2 equals 2 times 2 plus 4. Amazingly, our slope is going to be 8 again. So y minus y1 equals m times x minus x1. So now we're going to get our tangent line. We're writing it in point slope form. So y minus 7 equals 8 times x minus 2. And we would be all done. All righty, folks. Well, that kind of brings us to a close here. I'll see you tomorrow. We'll talk about one more type of limit, and we will call it a year.